Hey guys, I'm going to do the FRAPPY right now. Just explain it a little bit. A statistics teacher has 40 students in his class. 23 are females, 17 are males. At the beginning of class on Monday, the teacher planned to spend the time reviewing an assignment due that day. Unknown to the teacher, only 19 of the females, 11 of the males had completed the assignment. The teacher plans to randomly select students to do problems from the assignment on the whiteboard. A, what's the probability that a randomly selected student has completed the assignment? Okay, so 19 plus 11 right there is 30. And we have a total number of outcomes of 40, right? Total of 40 students. So 30 over 40 is 0.75. So the probability a randomly selected student has completed assignment is 0.75. Part B, are the events selecting a female and selecting a student who completed the assignment independent? Justify your answer. So F, we're going to represent selecting a female. C, selecting students who completed the assignment. Remember, to find independence, that means the probability of one event would equal the probability of that same event given a second event, given that a second event has happened. So that second, if they're independent, that second event has no effect on the first event's probability. We're doing right here, F is selecting a female. C is selecting a student who completed the assignment. Sorry for the handwriting there. All right, so the probability of selecting a female right here is 19. So because, I'm sorry, no, 23 rather. I don't know why I have that circled. So right here, 23 females in total, my fault. And there's a total of 40 people who did the assignment. So that's going to be 23 out of 40. Now, the probability of selecting a female given that that student completed the assignment. F and C, the probability of F intersection C, let's see here, is female who completed the assignment. There it is right there. That is 19. And the probability, just the student that completed the assignment right here, how many completes we have? 30. Yeah, the probability would be 19 over 40 divided by 30 over 40. We don't need to do that. Just, we have a table here. So it's just going to be 19 over 30. There we go. All right, so we get the decimals right here. Selecting a female is 0.575, but it looks like the probability increases when it's given that they completed the assignments. So the probability of selecting a female increases when it's given that that student completed the assignment. So just state that in the answer. I said right here, the events selecting a female and selecting a student who completed assignments are not independent. When given that a student completed an assignment, this increases the probability that the student selected is a female. So, any way that you want to say that, right? Or, the probability of selecting a female increases when it's given that the student completed the assignment, if you want to say it that way too. Okay? All right, so that is part B. Let's go to part C. Let's see here. Describe how to use a table of random digits to, let's read this. Suppose that a teacher randomly selects 4 students to do a problem on the whiteboard. Only 2 of the students have completed the assignment, Describe how to use a table of random digits to estimate the probability that 2 or fewer of the 4 randomly selected students completed the assignment. All right, so we randomly selected 4 students. We're doing some simulation where we randomly select 4 students, and we want to see if only 2 or fewer have completed the assignment. All right. So in this observation, it was 2 out of 4. That's 50%. The reason it's weird is because in the population, it was 75%. So we're trying to figure out if 2 or fewer of the 4 randomly selected students completed the assignment. Okay. So what do we have right here? Now remember, our population probability is 30 over 40 that a student completed the assignment, if you recall. All right, so we're going to right here represent, let 01 to 30 represent completing the assignment, and 31 to 40 represent not completing the assignment. So the first 30 completing, the last 10 is not completing the assignment. So that's like a labeling part. And then we will say we will use a table of random digits to select 4 unique 2-digit numbers, reading from left to right, from 1 to 40, and we're going to ignore repeats. So right here, we're selecting 4 actual 2-digit numbers. Remember, it's 2 digits because right here, they're forcing us to use a table of random digits. From left to right, from 1 to 40. And we're going to ignore any repeats. We're going to then count how many numbers we have from 1 to 30. That's our completes. Okay, so right here, we're going to go and we will count how many numbers we have from 0, 1 to 30. That represents our completes. Now remember, we're trying to do a simulation to see if we get 2 or fewer. So we're going to perform this simulation many times. We're going to count the total number of times we have 2 or fewer completes. That's from, 0, 1 to 30, out of the total number of simulations. Okay? So notice how I did this. I did like the labeling part right here. That was what 0, 1 to 30 and 31 to 40 represents, right? Then I did our random device part right here. We're going to use a table of random digits. That's our device. And we're going to select 4 unique 2-digit numbers reading from left to right, from 1 to 40. We will ignore repeats. And then we're going to count how many numbers we have. So then we're going to go and state, okay, how are we going to answer this questions? We count how many numbers we have from 1 to 30. We'll perform this simulation many times, count the number of times we have 2 or fewer completes out of the total number of simulations. All right, so let's go and do this trial right now. Let's see here. All right, trial number 1. Let's see here. We're doing the first 4 numbers, 2-digit numbers, from 1 to 40 is what we're looking for. Remember, don't forget that. We're looking from 1 to 40. All right, trial number 1, we have 12. Yes. 97. No. 51. No. 32. Yes. 58. No. 13. Yes. 4. Yes. Okay, that was all from 1 to 40. Now we're going to see how many of these are completes. And we want to see if we have 2 or fewer completes. All right, so 1 to 30 is complete. So there we go. No. There we go. And there we go. So we have, this is 3 completes. That is a no, because we're trying to find 2 or fewer, if you recall. Let's go to trial number 2. All right, so we're going to start right here at 84, right? So let's see here. So we have, oops, sorry. So we have right here 84. No, that's too big. 51, too big. 44, too big. 72, too big. 32, there we go. 18, there we go. 19, there we go. And 0, no. And 3, there we go. Okay. So let's see what we have right here. So we're looking for right here. So we had 18, 19, and oh, I'm sorry, I messed up right here because I just noticed this is hard because it's so small. But this is 18, 19. This is 40 right here, so I should not have gone that far. So let's get rid of that 3. This should be 40. All right, so there we go. All right, so we have this here. We're trying to find out from 1 to 30, what do we have? No, yes, yes, no, right here. So we have right here 2 completes. This is a yes, right? We're 2 or fewer completes. This is a yes. There's 2 or fewer here. Let's go to trial number 3. Let me make this nice and big so I don't make a mistake here. There's the first one that is not valid, right? 36. That is valid right here. Remember, we're doing from 0 to 40, so 36 is good. All right, then we have 0, 0. That's not valid. 24 is valid. 28 is valid. 96 is not valid. 76 is not valid. 73 is not valid. 59 not valid. 64 not valid. 23 valid. All right, so right here from 0 to 30 we have 1, 2, 3. So that's 3. So this is a no. So right here we have 1 out of 3 trials with 2 or fewer completes. So 1 out of 3 trials right here with 2 or fewer completes. Okay, that is it right there. Okay.